Okay, this is college. Oh, okay. This is college algebra. I didn't want this view. Remember, we didn't like it. Okay. This is college algebra. 15th, 14th, September 14th, 2020. And we're going to continue our chapter 2.5. We actually now, we're behind schedule with our syllabus. Oh, let's see, what is the PowerPoint? Yeah, but we're behind schedule because it took us a while to explain this. It took me a while to explain this, but we'll make it. No, so let's finish this. This is important. I guess I need to leave more space, more time next year. Okay. So what was the thing we struggled last time? Was annotate that if we have a function, this is for the one of us, those of us who think too much, like me and Tim. Elizabeth, she's more practical, but if we have a function, so if it's like x squared, right? And you want to find what happened to a function, let's do a different color. Oops. Okay, don't start over. So if the parent function, it's it was x squared, I want to make a function which is g of x, which is like, let's say, flipped, right, upside down, and then you want it, let's say, 2 units up, right? This is what we're recording, yes, the board sharing, okay. So what happens, the question was, if you take the function and first you do the shift, like if you do, let's say, h of x equals x squared plus 2, right? If you do this first, and then now we want to flip it, we're thinking, oh wait, should you flip the whole thing, or should you just flip the x squared? And the problem was, I was explaining that we're transforming the parent function. So we should just look at the parent function, not the whole, because this is not the parent function anymore, it's something else, right? And those rules apply only when you're like transforming just the parent function. Because if you do this, it was going to be like, if it was like that, it's going to flip this way, the whole thing. Let's make it orange, right? But this is what not we wanted. We just wanted to flip it like that, right? So we have to just flip. So this is no, right here. So you just have to put the minus, even though you have the 2, you're flipping just the parent function, right? So do not do anything to the 2. Because you can, the order doesn't matter. You can do first the flip and then the 2, right? Are you confused now? Yes, yes. Super sure. Uh-huh. Yeah. Okay. Well, I struggle with this too, because usually whenever, when people explain, they never explain this. And I was like, I could never find a video which explains it. And then finally, I just drew some graphs, put points, and this is the, what we want to do. So let's do, okay. Do you remember any of the Alex problems? Maybe you can give us one. Because there is more, there is more than that. There is shrinking, and maybe you had to do other things, Elizabeth. You're not ready for them yet. Yeah. So let's just finish. Okay, let's continue, and then we'll do problems. Okay. So what we're going to do today, after we learned flip, like reflection, and we learned shifts, vertical and horizontal. Now we're going to do stretching and compressing. So what is that? Okay, here we go. Starting right here. Okay, so we have, let's just look at the graphs right here. Here we go. See the graphs? So the original one is the black one, right? So let's get a point on the black one. Let's say this point. This point right here. What did we do? Oh, 0, 1. Okay, let's do 0, 1. Hold on, let's erase this. Okay. Oops. Okay, let's just take one. Let's just see first what happens with 1 point. Okay, when is this day? I don't know. Okay, okay, this point, the problem is, okay, so what we're going to do in this case, what are we changing? This is the original, this is the parent, right? So what has been done, the y, the whole function, the whole function, the parent, has been multiplied by 1 over 10. This means we're going to change the y value. I don't know if it makes sense, but you know, we're changing the y value. So the problem is when it's 0, it's going to still 0. So this point was not very good one. Let's get another one. Okay, what is this? What did I do? It doesn't want to erase. Okay. So if we get okay, so let's get this point which I originally was trying to get. Right. So the y is 0.5, let's say, right? Y is negative 0.5, seems like. Almost, right? So what we're going to do, we need to multiply this by 1 over 10. Let's make this, okay, 1 over 10. So what's going to happen? This would be 0.0, one more 0, right? 5. This graph is not very good, but it be right here, right? It went there. Okay. Let's get another point. This graph is not very nice. Okay. Wait, is this really? Yeah, okay, this will happen. So let's take this point. Let's take this point right here. Okay, let's take this point, right? What is the value? 0.8, let's say, right? So if we have 0.8 and we are multiplying by 1 over 10, this is going to be 0.08, right? So this point is going to be right here. This is 1, right? So 0.08 is less than 0.01. So went right here. So this is not a very good graph for that, but this is what happens. When you multiply the y by a value less than 1, the function kind of flattens, right? And because you're affecting the y, this is called vertical. I'm talking about first vertical. So this will be vertical shrink or stretch. It doesn't make sense, kind of vertical shrink, but okay, it's shrunk. So this is the thing what you're doing. If this is the vertical, right? Yeah. So if I say if this is like function. So if I'm vertical shrink, it's going to go this way. This means the y value went down. Yeah. So if I want vertical stretch, from here would go like, the y value would go up, right? This is when you talk about vertical. That's why, because if you look at the y-axis, with respect to the y-axis, different things are happening. You just focus on the y, right? So this was vertical shrink. Let's do the next one, which would be, oh yeah. The next one is going to be vertical stretch because we're multiplying by the number bigger than 2, larger than 1. See it here? Again, we're multiplying the y, which is the whole function. This is the whole y. So this is the y. Technically, right? So what is going to happen? This value, which was here originally, would go right here, get a higher value. So the function is stretched vertically with respect to the y-axis vertically. So now let's do the x-axis so you can see the difference. Okay, oh, they flipped it too. Okay, this is the same function. They not only stretched it vertically, but they flipped it too. Right, okay, so let's go do the horizontal. Here is a horizontal. So what happens with the horizontal? Okay, let's erase. You're going to affect the input, the x, you see right here? So it's going to be inside the function. So we're going to stretch or shrink the function, but with respect to the y. So what you do, okay. So let's see, let's erase. And of course, you know how x was always backwards? This is what it's going to be, okay. So here is the original one, is the black one again. All right, the black function, right here is the original. So what has been done, so the function does cubes the input once and then just subtracts the input, all right? This is what the function does. X, because x is the input. So the functions like if we have y equals 2x plus 2, this function doubles the input and then adds 2 to it, right? This is what it does. Well, this function here we are looking at cubes the input once and then subtracts the input from it. This is what the function does. So what we're going to do, we're changing the input right here. Instead of x, we're putting 2x, right? See what's changed right here? The inside, the input was changed, not the y. So then what happens, you know how the x is the opposite of what you think it happens. If you're multiplying by 2, you think it would stretch, but actually shrinks, right? It's the opposite. I can explain why, but just is it easier to remember that on the x, everything is opposite of what you think. And so if this value of x, see, like this value of x was here, of y, right, with this x. I don't know if you can see it, but I'm moving. You see the red? It's the same value of x, but it's shifted to the left. You see, it's the same value of x. And the reason is, so, okay, this function, whatever you give it for the input, is going to give you output. You know, it's kind of program. So it doesn't matter what you put here. The function all cares that if you put here the number 1, oh no, 1 is at 0, okay. If you put here the number 0.5, right, total, the value function would be that, right? And so the idea is how you're going to, if you want to make this 2x, so you want 2x to equal 0.5, right? So we're going to have the same value of the function if you solve this for x, right? X equals 0.5 divided by 2 is 0.25, right? So you're going to get the same value of y for x is 0.25 for a smaller x. Okay. Okay, let's look at, think of this. Okay, if we have y squared, okay, y equals x squared, all right? So when x equals 2, y equals 4, right? Okay, when x equals 2, I don't know if you like, it's so hard to explain when we're doing it this way, but okay. When x is 2, right? Y is what? 4, right? Just example inside. When x is 2, y is 4. So then if I want to achieve this value, if I decide to put, so this is what it does. You give it 2, it gives you 4, right? Put input 2, output is 4. So if I decide that I want, instead of x, I want to have like some smaller, let's write 2x right here, right? Right. I still, if I want to get 4, I need to get 4, I still need to have this to equal 2 somehow, the whole thing. Doesn't matter what it's inside, right? So then I need to have 2x equals 2 or x would equal 1. This means that if I do 2x right there inside, I'm going to get the same value, which is 4, for x equals 1 this time, right? It's kind of, okay. This is y, but all I need to do, honestly, just remember, x does the opposite of what you think it should do, right? Okay, so let's see. Yeah, so this is, so when you look at the x, you know, when you look at this graph, flip it mentally, because, you know, shrink and stretch makes sense to me, like, okay, this is stretch, this is shrink, right? So when you're on the x-axis, the same thing is happening, but if you do, if I do stretch and I'm looking at the vertical, it's shrink, I mean, whatever you do to the y, if you do this, it looks bigger on the x, but actually, so what you do, mentally flip this graph in your head, mentally flip it, right? So now what happens to the value of x? It shrunk. From here it went here, right? See what's happening on the x, shrunk. Let's do the next one right here. This is stretch. Yeah. So this is stretch. First, don't worry about what's going on. Stretch. So flip it mentally. What happened? From here, the x value went over there, right? The x value got bigger. So it's stretch. So it's stretch on the x-axis. Get it? So you need to think in your mind, are you looking at the vertical or the horizontal? And if you're looking at the horizontal, imagine the whole flipping, so your horizontal becomes a y, right? So if the value of x gets bigger, you stretch. If the value of x gets smaller, you are shrinking. Okay, so you can flip it too if you put a minus. Okay. And that's it. Now let's do problems. Let's do problems because, okay, let's do the explanation. Let's put it in practice. So what we're going to do, we're going to open the whiteboard and do problems. Okay, whiteboard, shared. Let's see. Vertical horizontal stretching. So let's do, okay, example 3 in the book. So it's on page, write it down. You get it down. So page 205, example 3. Yeah. We have a graph there. We have several points. So what we're going to do, we're going to just transform the points, right, and see what happens to the graph. See? Okay, I don't have, it will be hard to draw the graph, but I'm taking the first point. The first point is -5 and 0, right? So we're going to apply A, B, C, D, and E to this. Okay, let's apply A. So let's do blue here, okay. So I'll write the points actually, okay, after that. So A, you need to do 2f of x. Oops. So A would be 2f of x. B is 1/2 f of x. C is f of 2x. D is f of 1/2 x. And there is something like E. And this is f of -1/2 x. Okay. So the points are, I'm writing them on top with pink, -5, 0, -2 and 2. The next one is 0 and 0, and we don't need all of them. We just do 2 and -4. We ignore the last one. Okay. Because they will do the same thing. So let's do the first thing. First, so this is the f of x, our function there, right? This is f of x, those points. So what we want to do is to, what are we doing? What is 2 times f of x? What are we going to do to this function in A? Yeah. Yeah, so then what would you do? Can you say in terms of shrink and stretch and with respect to which axis? Okay. Yeah. So what is this called? Vertical or horizontal? So it's vertical, what, shrink or stretch? Stretch, okay, yeah. So this is where you get again. So this is what you're doing. You're right, vertical stretching. So let's see how this affects the points. Okay, so the x would not change, right? How should I have done it? I think, hold on, let's revise. Let's revise my writing. I think it's worth take the time and write the points again nicely right here. If you're after visual pleasing.
What happened to your this plastic or glass thing?
Oh, the thing you can draw on the graph with the magnet. No, what happened to it? It's dirty?
Yeah.
Wow. I think what happened, maybe the cleaning people decide to clean it or somebody, and then all the dust from the...
It looks like somebody put like a wet, dirty rags on it.
Yeah.
And then didn't clean it back up.
Yeah. Whoever was cleaning. You see who was the cleaning person. I think the same person tried to clean the thing with the piggy and ruined it. I don't know who it was, but because they scratched it with maybe one of those cleaning wipes and it scratched all the glass. So, okay. So let's put the point. It's okay, we'll find them. So -5 and 0. I want to put them here so I can change them under it. Then -2 and 2. And the next point is 0 and 0. The points. And then -2, what is it? Oh, 2 and -4. Okay. 2 and -4. And the last point is 4 and 0. Okie dokie. So what? Let's transform the points first. I'm just red. Red. Okay, so minus 5 and 0. What is going to happen to these points when I do this vertical stretch? How is it going to change? That's right, because the x is not changing, and the y, we're multiplying the y by 2, right? It's going to be 2 times 0. It's going to be 0. So the first point didn't change. Let's do the second. So what's going to happen to the second point? Tim? The negative 2 and 2? No, we're still on A. We're going to go through each point on A. So we're just going to do A for each one of those points. So we want to stretch vertically each one of those points. So what's going to happen to B? To minus 2 and 2. First the X, you know that X and Y, is the X going to change? No, so it stays minus 2. So what's going to happen to the Y, which is 2? That's correct, 4. Okay, next one. They're easier than you look. Okay, what would happen to this point, 0 and 0? Nothing. Okay, how about the next point, 2 and minus 4? What happens to the X? Okay, and so what would be the Y? That's right. So the last point, X stays the same, Y 0, so 0 times something. Okay, we got it. See? So look at the graph in the book, the red one. See right here? So just what happened is stretched vertically. See how got extended? Beautiful. So now let's do B. B, we can do it with what color? Like green. Okay, B is green. Okay, so what's going to happen to the point negative 5 and 0 for B? Yes, oh yeah, we forgot to say. Yeah, it's going to shrink vertically. So what would happen with the coordinates of minus 5 and 0? What would they become? You can look at the coordinates.
That wouldn't change. Right?
No, because the x didn't change and you're multiplying 0 by 1/2, nothing changed. Okay, how about the next point, 2 and minus 2? What's happening to it? So this is what we're changing. Negative 2, actually it's 2 because you're multiplying. Okay, so negative 2.
Oh wait, we're multiplying
the y. Yeah, no. Yeah, that's why I was highlighting the original. We're doing the originals, right?
Okay.
Oh, you're right, Tim. We're doing the original. Oh, don't come back. We're doing the originals. That's why, not the. Don't do the red. Do the one I am. We're doing the original ones. You're doing the A. Let's put the line. Oh, you were okay. So let's see.
Oh, wait, no, I wasn't.
You were not. So this is minus 2. Good thing we have Elizabeth. So you need to multiply the 2 by 1/2. So what's that? That's correct. So this is what happened. I know it's confusing. So I'm trying to see how to. Okay, I know. We're going to black them off. Hold on, with the black. Oh, we're going to do this to those. Ooh. Try to hide them. Can you move it a little bit? Oh yes, perfect. Now we're looking at the right ones. Okay. Okay, so what happens to the next point, 0 and 0? Okay, next one, 2 and minus 4. Correct, last point. Yeah, okay, dokie. See, okay. So C, let's do C. I'm going to hide this and you can tell me, explain like in English what happens to the function in C. That's correct. So it shrinks horizontally. Again, we think about the x-axis and then it's the opposite of what it says, so it shrinks. Okay, very good. Okay, let's say what cover should, it doesn't matter the cover, I'm hiding them anyways. Okay, so what's going to happen to the minus 5 and 0? So what we need to do to the x, actually, instead of multiplying it by 2, we're going to divide it by 2. Or you can think this way, another way to remember it, take your 2x. So 2x should now equal negative 5, right? Because the input was negative 5 to get this value. So now, instead of negative 5, you need to have 2x. So 2x is negative 5, or x is negative 5 over 2, which is negative 2.5. Yeah. Another way to think about it, I don't know, this might be confusing. You see, this is how Tim is thinking about those, I know already. It says multiplied by 2. Do the opposite, divided by 2. See how it says times 2x? Just do the opposite, just divided by 2. Yeah. Erase this too. Okay. Which things? Are those? Yeah, I was thinking yesterday that they had some kind of ugly plastic thing. I figure out, wow, theirs broke and they just put some ugly plastic temporary with their logo. And today they're changing it. Whoa. I don't know what happened to the previous one. There was temporary one. Maybe the wind. Okay, so let's go back to our function red. So what would happen to, okay, we said it's negative 2.5 in 0, right? Okay, let's do the next point. What's going to happen to negative 2 and 2? Yeah, and how about the y? That's correct. Okay, next one, the 0 and 0, what happens to it? Yeah, how about next one? 1 and negative 4. Okay, how about the last one? 2 and 0. You see, it's not too bad. Let's look in the book. We forgot to look at B, but you see B kind of shrunk vertically. Then C, where was the original? The problem is original was the previous page, but C shrunk horizontally. If you look on the horizontal value, they got smaller. Okay. Hey, moving on. D. So can you say it with words in a sentence? What happens to the function in D? It stretches or shrinks? That's right. So horizontal stretch. Okay, so let's get going on the coordinates. So what's going to happen to the first point? So the negative 5 and 0 would become what? That's correct. Negative 10 and 0, right? To the opposite. If it says, so essentially your 1/2 x should equal minus 5 this time. So then you need to multiply by 2, right? No. No, depends on where. Oh yeah, definitely, yeah. Because like when the computer does, you know how everything is done with the computers now. I even watched this movie. It's called Primal. Nicolas Cage's new movie. I don't think he used to be a great actor. I don't know what happened to him, but this movie, I mean, he's okay, but this movie is about a guy who caught some white jaguar, very rare, and he's transporting it on some kind of, with the boat, and there is some criminal also. The FBI is carrying, one like Dr. Lester almost, very big, great killer, and then the prisoner escaped in the jaguar. But anyway, the point is that the jaguar was computer animation. All the animals now, they're computer animation. They don't use wildlife animals anymore, which I don't know. You can see it's computer animation, like the latest Mowgli. The latest Mowgli movie. It's all the animals are computer animation, so you can see there is a difference. But anyway, if you have to, you draw a house, and if you want to move it, you just tell the computer. So the computer is doing sometimes, shrinking, stretching. These are like commands. Yeah, and example. Who? Uh-huh. Mm-hmm.
He works on the CNC.
What are CNC machines?
It's like you program the machine to like cut out parts and stuff like that.
Oh yeah, definitely. I learned this in high school somehow. Okay. Yeah, so you need to, they have like comments, do this, but this example. Okay, let's finish here quickly because here is my house. So what happens? So multiply by 2. Okay, got the idea. Let's do E now. Imagine we finished with D. Now we're going to do E. So what happens? Yeah, let me just get the, let's try to say what happens first. What has been done to this function? So yeah, so let's first, so it's going to be, two things have been done. One is, what's the name? Shift, and the other is stretching or shrinking, right? Not shift, but flip, what, a reflection, okay? One is reflection, the other is stretching or shift, two things. The minus means one thing, the multiplication is another.
Oh,
It would be,
Right.
it would be reflected, right? That's what-
Yeah, reflected, yeah.
And then it would expand, but
So let's ignore the, okay, if ignore the minus, let's do the shrink or stretch first. What has been done?
it stretches. That's the word that I keep forgetting.
So it stretches along which axis?
X.
Yeah, so it's horizontal stretch. And then it's a reflection with respect to which axis? No, no, you need to think. Let's think about any simple graph. If you have something here, right? If you want to reflect this point, let's see this point right here. If I want to reflect it with respect to this axis, what would happen? The y would change, right? If this is x and y, this will be x and negative y, right? But if I go the other way, if I go this way, the y would be the same, but the x would be a negative here, right here. So this point would be negative x and y. So the reflection is with respect to the y-axis, right? Because the x has become a negative. See? Okay, so there are two things done. First is the shrink or stretch. We figure out the stretch of the x, all right? So you can forget for this for a second. Then you have minus negative x, right? So you're going to flip it on the x. From a positive x becomes a negative x, right? So it's a reflection with respect to the y-axis. So now again we're affecting only the x because it's the input. So let me get rid of the scratch. So let's do the minus 5. What's going to happen to minus 5? Okay, so first is going to be multiplied by 2, and then it's going to be made a positive, right? Or we can just think about this way. Minus 1/2 x should equal negative 5 somehow. What do you need to do? Multiply by minus 1, right? It's times minus 1. See? Then the minuses are gone, right? So then you have 1/2 x equals 5, and then multiply by 2, so x equals 10, right? So the new point would be actually 10. Because what you're doing, again, let's start. You're changing the x first. So we're forgetting about the y, just looking at the x. So what has been done to the x? First, two things have been done. The first one is there is a stretch, right? So what happened? If you have 1/2 x, this means you need to multiply by 2. So here minus 5 becomes 10. Step 1. Then focus on the minus. You know, it needs to be a negative. You have negative 5 was your point. Now it's negative 10. So put another negative in front, makes it positive. All right.
so why is it separate though? With the 1/2?
I mean, they're all there. You can apply it at the same time. See how if you just set up the input to be the odd input right here, right? You can do it one at a time. But if it's easier for you to think what's going to happen, you can like do it. If you're doing it by reasoning, step by step, you need to split it. If not, just set up your negative 5 to equal whatever is inside, and you get what the value would be. Okay, let's do it. Okay. So let's look at the graph. It is E, so it's right here. So it's upside down. I mean, also upside down is from left to right flip. You know how this round part here was on the right? Now it's on the left.
So it's flipped on the y-axis.
Yeah, across the y-axis. Yeah. Flip like this way, right? And also got stretched. Stretch it. Okay. Okay, then another example. I think it's good. We can practice more. Example 4. Okay, let's do example 4. So that's why, Elizabeth, you were not doing those because you didn't know all of it. We last time we did only part 1, which was like left, right. Okay, example 4. Let me write it down. We're going to conquer those. The next time, I'm going to leave more time. For some reason, I remember last year the time ran out again, so it's not just class. So maybe it's the online thing. What is it? Example 4. Okay. It is. It's amazing. So simple. It's from last week too. So it's just fun. Oh yeah, take it. I don't think it's kind of. Just take it. You know. I don't say it on. I don't want to say it on the video, but I'm saying it. I guess we should not be eating it. So, example 4. Okay. So what is here? We have again points. Or are they the same points? Oh, I erased them. These were the same points. Okay. We write them again. Or let's just write. What do you need to do? What do you need to do? What we need to do is the same points, but we need to do this to them. -2. Oops. -2.
This is where I struggle.
Okay, we do it now. -2 f of x minus 3 plus 1. Okay. So this is the transformation is right here written as y equals. Right? This is our transformation. Let's write here with blue. This is our transformation. Okay. It's our transformation. So now we have the same point. I'm going to write them down and we're going to transform them. -5 and 0. See? -2 and 2. 0 and 0. For some reason it's slower when we're doing it like this. But, okay. 4 and 0. And one thing I noticed, because when I talk and there is still smoke and my voice is getting like yeah. So what do we need to do? Let's get the first point. Okay, -5 and 0. Okay. So what has been done? We have x and y, right? X is the, let's write it with a little red, I guess. This is x and this is y. So let's see first what's been done to the x. One step, but now we have x to transform each one. So what has been done to the x in this? Y equals to f.
It has been moved
Uh-huh.
to the right to the spaces.
Yeah. So this is, if you think, you know, there are 2 ways to do it. Again, you can set it equal to something, or we can think in your head. Let's think in our heads first. So we have -5, and it needs to be moved. So it's negative, so you need to go to the right. So where is it going to go? If you move -5 to the right 3 spaces. -2. Okay, so this is one way to do it in your head. The other way. So remember what we were doing earlier. Let's see. And again, in the book, they just didn't say how to do it. You know, they expect you to do it this way, but another way, again, let's see, blue, maybe purple. Let's do this purple. So this is the input, x minus 3, right? I want this input to equal the x minus 5. So you can just do x minus 3 would equal -5, right? Because you want the same input to get the same output. So if you solve this, x would equal -5 plus 3, or x equals -2. I mean, this is the same way we were doing earlier. Now, because your input, so this is the thing, you know, the function one input is one output. What we're doing, we're changing how the input looks, but if you want the same output, you need to put the same value in there, right? So I want the value in here. I want this to be -5, right, to get the same output. The question is now, I want my x to look different. So So what should be the new x to give me the same value of y transforming, right? Yeah. Okay, so let's erase this part. You can go and watch the video again if you need to. So let's do this. Okay, go.
One good thing about all this online stuff is now I can go and rewatch the lesson.
No, but you didn't watch the one I said last time. And how I know, because I put something, and only one person watched it. From the beginning of the semester until now, only one person watched video. Maybe there was a few videos I didn't put anything in it, but from the videos I put some stuff in, only one person really watched them. I don't know. I mean, the one with Alex, they just do Alex, I guess, and then say they don't know what to do. But I know this is one person who's watching it. Okay. So then this is, so we figure out what we figure out. Okay, so you can do purple. Okay. So the 5, negative 5 became negative 2, right? So what has been done to the y? Now let's transform the y. Okay. Yeah. Yeah, the y down 2. No, the y has been multiplied by negative 2, right? But the y was 0, right? Yeah. The problem is it was shifted. After that was right. Okay, so first thing, you need to multiply the y by negative 2, right? So it stays 0, but then you have plus 1. Then it has been shifted after all, right? Okay, see, so the first time you can give minus 2 times 0, right? It's still 0, this one, right? But then you're shifting it 1 unit, so plus 1. So now the whole y is going to be a 1 because 2 things have been done to the y, all right? So the new point is going to be negative 2 and 1. Look in the book. Okay, let's look at the book. See how first, so what did we do? Shift units to the, okay, they look at the same graph and they kind of shifted it, right? We take the graph, units to the right, you know, they shifted it. Then they stretched it vertically, right? Yellow. Then they flipped it, right? With respect to the x-axis, and then the last they shifted 1 unit up, right? It's the whole thing. Okay, so we just did it one step at a time. Okay, let's do the next point. Okay, and you can, okay, next point. I don't know if it's easier to do it point by point or just look at, but you know, you have to see what's happening to each point. I think it's easier on the graph. Okay, let's do the next point here on the paper, on the thing, and then we do it on the graph. Okay. So the next point was negative 2 and 2. Okay, what has been done to the x? So what would the x be? Okay, yeah, because you have minus 3, I mean, x minus 3 should equal negative 2, or x equals 3 minus 2, which is 1. No, it's 1. 3 minus 2 is 1, right? So the x will be 1, right? Because what happens, you get negative 2, you're moving in 3 units to the right, and so it becomes a 1, right? Here, if this is the number line, or this is the thing. If y was here negative 2, oops, negative 2, right? And you're shifting it 3, okay. I pressed the wrong button. This means we lost all of our writing, but it's okay. You got the idea. The whiteboard. Ooh, pen. I hope it didn't break. Okay. Okay. Well, good thing it saved our whiteboard. Yeah, so it is possible, right? If you move it. Oh man. So move it 3 units, like 1, 2, 3.
Yes.
But you can also do it this way. So 1. So what happened to the? So this was the x. So what is going to happen to the y, which was originally 2? So first do this part. First do this. That's correct. So the y's, whatever it's done to the y's is the same thing. So negative 2 times 2 is 4, and then negative 3. That's correct. So you can look at your final. It's right here, 1 and negative 3. Right there. Okay, so now let's do this. Let's make it easy. Now we know how what's happening. Let's look at the next point. We can just do this. Okay. 0, 0. So x is 0. So what's going to happen to x? So it's moving to the right? So to the right, 3. Number. Then the y. You have to multiply the y by negative 2, technically. So you can actually not just multiply between the negative 2, just multiply by negative 2, right? So multiply the y by negative 2 is going to become still 0. And then when you add 1, it's going to move 1 later. So that's what it is. This is what it is. Let's do another problem. Do it now yourself. It's not it's not as hard as I'm trying to explain it. It's easier. Probably okay. The graph maps the function with one of the okay. Let's do this. Let's do on page 7, on page 211. Let's write it down. Page 211. Let's do problem 71 through 78. We have to match the graph with the function. See right here. Page 211, 71. We have the graphs and there are the functions, 71 to 78. Okay, so let's look at A. Wait, what's the question? Okay, the A is the original. A is the function. Yeah. A is the what we start with, f of x, seems like. Okay. So let's see in B. Don't worry about them, we'll figure out later which one is A. Let's do B. So what has been done to this function in B?
It looks like it's been shifted to the left too.
In B, everything is B?
Yeah. It's compared to A, right? It's
Yeah.
shifted. Yeah, so
Yes. I see that.
yeah, I think
Okay.
it's 2 to the left.
That's right. Okay. And left is the other. Yeah, it's okay to the left, and then what?
Flipped on the y-axis.
Okay. So look at 71 to 78. Which one do you think is that? Oh wait.
Would it be 78?
It is. Actually, what we're supposed to do is backwards. I don't know what I mean, we can do it any way we want. Yeah. Okay. 70. Okay. So for 78. So 78 is A. We can do it this way. 78. The answer is A. I mean, it's B. Sorry. 78. The answer is B. Right there. Okay. Right. So we got this. Okay. Let's look at C and find which one is C. What has been done to C compared to D? Several things seems like.
It's also been moved to the left.
Okay.
By
Yes.
2 units.
Yeah. Okay.
And it looks like, I think it's 77, but it also looks like it's been flipped. Maybe.
No, it's not.
Oh,
Because it is the same
Yeah,
pattern.
77.
It is 77. Yeah. Look at that.
It's been shrunk.
77 is C. Okay, let's do another one. Let's D. How about B? What's the they're almost the same. Oh no, they're not. Okay, D. Which one is D? What has been done to? So look at the A, and then how from A we got to D.
It's been shifted to the right by 2, and then it's also been shrunk just about the same. So that means 75.
How was it is 75? Yeah. Okay. So you got the idea, right? What they have for look at 74. 74 is kind of which one would be, if you look at 74, look at the equation. Which one of the graphs would be 74? It's kind of tricky, right? It's like flipped on the,
Flipped on both axes.
yes, so this is tricky. I wouldn't have been singing if I didn't know what the answer was.
Would it be, E?
Where is it? No, because the only thing done is flipped and flipped. It's not being surround, moved up or down. For example, actually, it's the original. 74 is the original function. It's kind of hard because the function is kind of symmetric. You see how it's symmetric?
Yeah.
So if you flip it with respect to the y, you know, it didn't change. But then you flip it upside down, the whole thing changed.
Oh,
It's respective with it's symmetric with respect to the origin. So okay, but it's tricky. So I think you got it here. You can go home and implement the steps one by one, right, Elizabeth? And just one by one, you know, what's done to the x to the y slowly, you know. And again, we are transforming only the parent function, whatever it was. The order doesn't matter if you do this first or that, but you need to. Okay. So what you do for 5 minutes? We just look at 3, and the reason is 3 is where is 3? Yes.
Could you, so, looking at 74,
74. Yeah.
it has a negative x, and whenever it has a negative, all we do is just flip.
Right. Yeah, because this is what it is. Flip it once. So if you have the points, you just multiply them by a negative. If they are positive, they become a negative, right?
Because I don't know if that's one that we can.
Yeah, the x and the y, they'll be both need to be multiplied by negative. And so they will flip this way. Yes. Yeah, you should give it. Have questions? I mean, you might, but you can go back and watch the video a little bit.
That was really tricky. I was stumped for a second. I was like, what's going on here?
For 74? Yeah, 74. That's why it was kind of tricky. It's hard to see because, you know, it's like, is it, you know, need to really look at the numbers. They all they're the same.
And I clicked it.
Yeah. Okay, so let's see if you remember, what are the complex numbers? This is chapter 3.1.
I remember not liking them.
Oh, no, they're very nice.
It must be confusing.
Look into.
I just remember the imaginary.
Well, it's right there. Imaginary number is part of it. Yeah, the I. So a complex number.
I like imaginary.
Yeah. Okay. So let's see. A complex number is the complex numbers. It's like A plus IB. This is the general form. This is what the complex number is. So if you have the real numbers, complex numbers are above the real numbers. They kind of encompasses, and the reason is because every number can be represented as a real part, which is a real number, an imaginary part. All right. For example, the number 3 plus 2i. Right. It's better to write the B in front of the I, so it's sounds better. This number has imaginary real part of 3, imaginary part of 2. So if I want to write just the number 3, the real number 3, I would write 3 plus 0i, right? So this number would be just real. But if I want the number to be more complex than the real, you can add imaginary part. And there are many things how you can represent them on an axis. This would be the real numbers. This would be the imaginary number. Oh. So if this number is like here, this would be, let's say 2. Let's go this 4. So this number would be 3 plus 4i. Let's see. But this is another topic. If you remember in Math in Society, there was this guy who talked about the fractals. And he was explaining how imaginary numbers are actually, they're just number, but it's on a plane. It's not on the number axis, but now it's two-dimensional. And that's because it has 2 parts, real and imaginary. Anyway, but the I, remember the I here. So I was equal to what? What's the definition of I? That's right. This is the definition, right? So what is I squared then? That's right. You can stop right there. -1. Okay.
I'm getting the cobwebs out.
Right. So this is all you need to know. This is essentially this is the definition, but this is the most we're using this quite a lot. So just I mean the same. You know, if you square it, you get it. But just remember, I squared it once. So let's look at example 1. It says example 1. So page 237. And this was supposed to be reviewed. That's why I was not even actually had time for it. But example 1 said this is the number square root of -7. It says express each number in terms of I. Right, example 1. So what you do, you can split the -1 and the 7 like that. All right. And then since you know that -1 is I, this whole would be square root of 7I. Problem is, you know, I would like to write it here, but you need to be careful to make sure that the square root finishes right there. Right? Yeah. So when there is square root, sometimes it's better to put the I in front, unless you really like make sure it's behind. Okay. So how about another one? Do negative. Oh, let's see if you can remember how to simplify. How about do square root of -48 in terms of y, in terms of I, and simplify too. See if you can do it. Okay, so what it's going to be. So how can you simplify square root of 48? Remember. Not with the calculator. Okay, what you do, you can do the 3, you know, what was that? I mean, you know what is 6 times 8, but this is one way to do it. It's 6 times 8.
The smallest number possible.
Yeah, the prime numbers. The 3 brings you to the prime number, the one you cannot divide any further. I mean, this is you going to the basics, but it's okay. So what is the cherries on the 3? Oh, 1 cherry, 2 cherries. See? Oops, they even red. So this number 48 is I. So square root of 48 could be as 1, 2, 3, 4. 2 to the power of 4 times 3, right? Or 16 times 3 technically is square root of 48, right? So then how can you simplify this? You need to take something out of the square root. Yeah, but not not the exponent exactly, but you take the exponent. Okay. Okay, 16. Let's do it this way. Square root of 16 times square root of 3, right? So what's square root of 16? 4. So it's going to be 4 square root of 3 and the I, right? This is what the number is. If you want to do to take out the exponent as you're saying, you need groups of 2, right? So if it's square root, how many groups of 2 do you have of those 2's? So you have 2 groups of 2's, right? But you have the calculator, so you don't need to worry about. So you have 4 2's, right? So we have 2 groups of 2's, and every group comes out, right? Right. Remember that? Or another way to think about it, the most sophisticated way, would be square root of 2. What is a square root? It's a rational exponent. So the whole thing, you can do it 2 to the power of 4 times 3 to the power of 1 over 2. Remember that. Right? And then when you distribute the exponent, would be 2 to the power of 4 times 1 over 2 times 3 to the power of 1 over 2. And then you can do this, you know, we're going overboard now. This is 2. So it became 4. And 3 is just a square root of 3 because we cannot simplify it. We need to remember those basics. But I know we have the calculator, so yeah. So we need to stop here. But you remember when you go on Alex, you feel free to like do the imaginary numbers. Hopefully they're there. Did you see them yet? Okay. Imaginary. You see the imaginary? Okay, well, that's it. Oh, this is for the class because we need time to class over anyways. We need time to convert the recording. So now we need to stop the recording. Yay!